Hello everyone, welcome to 11 plus for success. There was a mistake here in two of my videos, so success is SUCCESS. Don't make that mistake that I made. Good. Again, today we are going to be working on prime numbers part 2. Okay, so we have in some 11 plus questions where you've been given a particular figure and you have been told to find out maybe 2 prime numbers or 3 prime numbers that will make up that figure, and it can come in any form. Sometimes you can have a question like this where you have a box, add a box, and then your answer is a prime number. Let's say in this case, let's say is 17. Okay, 17, and they're asking you what 2 prime numbers, and they must only be prime numbers that can make up 17. Now, if we use 2 add 15, 15 is not a prime number. If we use 4 add 13, 13 is not a prime number. 4, not 13. 4 is not a prime number, but 13 is. If we use 1 and 16, 1 is not a prime number. Okay? If we use 5 add 12, 12 is not a prime number. We can't use 6 add 6 either. Okay? So, in that case, do you think we are able to actually find this? Any prime number? Even if you say 17, even if you say 15 add 2, even if you say 17, okay, we can actually, even 11 add 6 won't work. Can you see? So there are times when that question, because I created this, I just tested it just to see if it's going to work. So you can see that that is going to take us nowhere. Even if I say 14, it's going to take us nowhere. Okay, so we can easily change this figure. Let's think of another one. Which other number can we think of? Shall we try excuse me, shall we try 18 then? And you know what, that gave us something, that gave us a big clue there, that the odd numbers, it might not be the same in all cases, so please don't mix it up. Sometimes we have, like what we have found out is that odd number as an answer, you really can't find 2 prime numbers that can make it. One will be and one won't. Now in this case where the prime number is, the answer that you are told to find is even number, let's see whether we can actually find out the 2 prime numbers that make up this even number. Okay, if I use 2 and 16, it's not going to work, will it? No. If I use 11 and a 7, look, odd, prime, even number. Okay, so prime plus prime, maybe it's always leading us to even number, who knows? Okay, it might not be all the time actually. Let me show you something. So if I say 2 add 18, prime, not prime. Okay, let's try, we can try. What about 3 add 17? Yay! What about 5 add 15? No. What about 7 add 13? Yay! Okay, so that means we have times when prime, odd, yeah, prime and odd add together will give us even numbers. Okay, that's one part. Now you can have a question again whereby you have been told to find indices, okay, of 2 prime numbers, and it will give you an answer. So they might say to you, find or they might say something like this: raised to power 2 plus that raised to power 2. So we're going to think of our own number now. I'm thinking. Okay, so let's see a question like this. I've just done a little scribble there. Okay, so they are asking you, there are two prime numbers. When you insert it into this box, two boxes, these empty boxes, with your indices involved in your calculation, you will get 34. What are the prime numbers? So I'm thinking now, what number can give me a 34? And I want to choose, let's say, I think of, let's say, 5, for instance. All you'll be thinking of is prime, prime, prime. Okay? Prime, 5 times 5 is 25. Oh, well, I got that. Any other prime closer? If I go to 7, 7 times 7 is 49. Can you see I've already gone past? And they didn't ask me to take away. And they didn't ask me for a negative answer. They didn't mention that there's going to be a negative answer. So I can easily check backwards again and say 3. What about 3? What about 2? 2 times 2 is 4. 4 plus 25 is not going to give me 34. But then if I say 3 squared, which is 9. 5 squared, which is 25. Okay, 25 plus 9 is 34. Okay, that can come in that form. Sometimes you can have the negative one as well, where they might say to you, let's say, box, empty box raised to power 2 minus empty box raised to power 2. Let's think of a prime number that can help us in that case. So let's say, I'm thinking again, okay? As I'm thinking, I want you to also think. As I'm thinking, think of a prime number, okay? Think of a prime number. So let's say, I'm thinking of my own prime number now. Okay, I think I got one. Okay, I'm not gonna tell you the next one there. Okay, so we got 40 as an answer, and they need us to make sure that two prime numbers, you find the indices and take away, and then you get 40. So let's begin to think. Looking at my prime numbers, what number can I think of? Let's say I'm looking through between 2 and 1 and 10 only. So let's say 7. 7 times 7 is what? 49. Okay, because I must get 40. So you need to think of a number that is so close, either a bit further or so close. So did I put 49 squared there? Don't make the mistake I made. Can you see? Instead of 49, I needed to put 7. 7 squared, 49. And I know that 49, take away 40, is going to give me what? 9, right? So then I know that this is 3 squared, because 7 times 7 is 49. 49 minus 3 times 3 is 9, minus 9, let me write it here, minus 9 equals 40. Yippee. Okay, so that's how to figure out questions where you have been given specifically to find a prime number to use to solve the problem. Now, sometimes they could give you also another question that looks like this. Let's go to another page, where they say to you that there are 3 numbers and they must be prime, and when you multiply them together, they must give you a certain number. So let's say the first one, we have been told we need 105, and you must use 3 prime numbers only 3 prime numbers to make up this 105. Okay, now first thing is, think of a prime number that can go through this 105. I know, of course, that 5 is a prime number. Okay, so divided by 5. 5 here 1, 5 here 1, 5 here 2, and of course 1. So I know that 5 is one of them. Now actually, we'll write our answers below. I know that 5 is one of them. Now I'm left with 21. And I know that 3 times 7 is 21. 3 is prime, 7 is prime. So that's my answer. Okay? Another one, they might say to me, find 455 now. Find 3 prime numbers that can make up 455. Again, because it's got 5 here, I can easily, cheekily believe that 5 is going to work through 5. Okay, so 5, again, 5 here 1, 5 here, of course, 0. 5 in 45 is 9. 5 in 5, 1. So I know 5 goes in first. Now, I've got to think of a number that makes up this 91. Now, I know that I might not find it in 1 to 12 times table, but I might find it a bit further if I keep counting. Okay, now let's think of a number that is very close to 91 in multiplication in the first set. I know, let's think of 89 or 88. Let's think of those numbers: 89, 88, 84, because 7 times 12 is what? 84. Okay, and I'm looking for 91. So let's see. 91, take away 84. 11 minus 4 is 7. Okay, and then of course 0, that's 8. Okay, there's nothing there. I mean, did I say 8? That's 0 really, because 91 take away 84. Yes, I remember what I did wrong again. 8 take away 8 is 0. Now I love this. That's why you will notice when I make mistakes, I don't cut that, I don't switch it off. I want you to see what mathematics can be about and how you can be creative. Don't be scared of maths. Just try, have fun, make mistakes, try to find out where the mistake went wrong, try to fix it. It's lovely. Maths is very interesting. So of course we have 7. So that tells me there is something about 7 and 13. Remember we said 12 times 7 is 84. So 13 times 7 is going to be 91. So my answer is 13 and 7. Okay, so that is it. Now if we try to work it out, you'll notice this: 13 times 5, 5 times 3, 15, remainder 1, 5 times 1, 5 plus 1, 6, 65. Now let's then say 65 multiplied by 7. 5 times 7 is 35. 5, remainder 3 here. 6 times 7 is 42. Plus 3, 45. That's our answer. So anytime you are given a question in that form, make sure you try and think of your times table, which number can multiply and which number is a prime within that times table that can multiply the other number in order to be able to make up what you're asked for. And you could have times when you are told one of them must be a prime number. Make sure you engage your thinking. And can I tell you something? You can only get this type of questions sorted, or these types of questions sorted, if you practice very well. So try as much as possible to practice a lot, because that's going to be pretty easy in your exam. Hope you enjoyed this session. Thank you for listening. God bless. Hello, welcome to 11 Plus for Success, and today we are going to be working on addition of fractions with a mixed number. Addition of fractions with a mixed number. So let's come up with a mixed number. Let's say we are given 2, 3 over 5, add 8 over 15, and we are told to calculate. Okay, we are told to calculate 2 3/5, add 8 over 15. Your first step, very important, the first step is to sort out this mixed number so that it doesn't confuse you. If you feel that's required, honestly speaking, I'll say to you that's the best step. So converting mixed number to an improper fraction goes first. So 2 times 5 is 10. 10 add 3 is 13. So we have 13 over 5 add 8 over 15. Step 1. Okay. Step 2 is add. So if you may want to write it there as step 1 is convert. Step 2 is add. So in order to be able to add this, we go to the next page. 13 over 5 add 8 over 15. 13 over 5 add 8 over 15. Okay, so for us to be able to work this out, we're looking at the denominators and they must be the same. But in this case, we only have one denominator that is bigger, and always look at the bigger denominator rather. So we know that this is 15, and we need to be able, because we can't find 15 in 5, but we can find 5 in 15. So we need to be able to make sure both denominators are the same, okay? And to be able to do that, we need to multiply this by 3. Notice I have not done anything here because we really need to be 15. So there's no point multiplying this by anything again. Now, whatever I do to the denominator must be done to the numerator. So because I multiplied that by 3, I've got to do that as well. So then what I get is 13 times 3 is 39. 5 times 3 is 15. Add 8 over 15. Like I said, if you notice, that stays the same. Now, what is 39 plus 8? You will notice that 9 add 8 is 17. The remainder 1, I add it here, turns to 47. My answer is 47 over 15. Now, there are times when they may tell you that you need to convert your answer to, or they might say to you, give your answer in mixed number as well. So we know that we got 47 over 15. Then we need to convert it back to mixed number. So how many lots of 15 can I find in 47? I know that 15 times 3 is 45. So my answer is 3. Big one. With the remainder, what's my remainder? 47 minus 45 equals 2. So I have 2 over 15. That's my answer. So you may want to also give it a try, come up with your own questions, and look into the previous videos that I've done in the past and see how to convert this type of questions, and especially working with mixed numbers, how to convert mixed numbers into improper fractions, and try and set like 10 questions for yourself. See how it goes. Thank you for listening. God bless.